You just created your first React project, hopefully using Vite. npm create vite at latest. But you stumbled upon a bunch of weird files and folders. So you started clicking around, trying to connect the dots, but the more files you opened, the more lost you felt. We are going to break down every single file, one by one, while building a mental map of how they connect. At first glance, we can see three main folders: src, public, and node modules, and also various configuration files that we can edit to customize our project. The .gitignore configuration file is used to tell Git which files and directories should be ignored when staging or committing your changes. So what about the package.json file? Picture it in this way. It's like a library's index. It lists all the top-level dependencies of the project. As any package that you install may also have its own dependencies, which are known as peer or transitive dependencies, a .log file is constantly managed and updated by your chosen package manager. In fact, it's automatically updated every time you install dependencies by running either npm install or npm install followed by the package name. In addition to listing top-level dependencies, the package.json file also exposes scripts, which are commands that you can run on your terminal, such as npm rundev, which starts the development server, and npm run build, which generates the production-ready bundle. So if the package.json file only lists the top-level dependencies and the .log file stores their corresponding transitive or peer dependencies, where does the actual code of the packages actually live? That's where the node modules folder comes in. Think of it as the actual incubator of those dependencies, or the third-party packages codes reside there. It's also known as the black hole folder in JavaScript's memes literature, because it simply takes a lot of disk space. So always double check that it's present in your .gitignore file. You definitely don't want to push that to GitHub. Now that we escaped the black hole, let's work through these TypeScript configuration files. Each one of these files helps you to customize the TypeScript type checking experience according to your preferences. Think of these files as the environment-specific rules of the type checking experience offered by TypeScript. First, we have the tsconfig.app.json file, which sets the rules for your frontend or React code. Then we have the tsconfig.node.json file, which sets the rules for the backend side or the logic that runs exclusively on the server. And finally, we have the tsconfig.json file, which is the parent file that is read first by the TS compiler. It holds references to the other two files. We've already customized Git, TypeScript, and npm, but what about our engine, Vite? That's where the vite.config.ts file enters the game. The file simply exports a defined config function, which receives a configuration object we can use to fine-tune how Vite operates. Since Vite works with most modern frameworks, we need to pass it the React SWC plugin to ensure the build process is compatible with React. React is just JavaScript, and as you may know, JavaScript can't exist in the browser without HTML. Similarly to how an athlete can't move his body without its bones. The index.html file is the entry point of the application. It defines the main HTML layout or template of all the pages that are served. Inside the head tag, we reference the /vite.svg file as a favicon. If you look closely, you will see that it's located within the public folder. Any static asset such as an image or video stored there is publicly served. You can reference those assets from anywhere in your code using a leading slash followed by the path relative to the public folder. The src folder holds all of our application's TypeScript code, including React components, their corresponding style sheets, and other logic. So where does all the JavaScript action happens? Main.tsx. React literally binds itself to the index.html file here. Inside the main.tsx file, we retrieve the DOM element of the div with the ID of root, using the document.getElementById method. The element is passed to the createRoot, a function imported from React DOM client. The function call returns the application's root object. After that, we make use of the render method of the root object to display the app component, where in example, counter component code resides. So instead of passing app directly to the render method, we first wrap it in a strict mode component because it makes catching bugs easier in dev mode. Now that we've briefly explained how React wires itself up and injects the counter code from the app component into the root div, let's start the app and see it in action. Let's open our terminal, type npm or pnpm run dev in order to start the development server. Open your browser and then head straight to http localhost 5173. Once you've done so, you will stumble upon this page. Now, in order to confirm that the main.tsx file is injecting the app component inside the div with the ID of root, let's inspect the page. Great, all the counter's HTML code is here, and it gets even better. The HTML is updating whenever we increment the counter. React is indeed reacting, and we are reacting to it. Isn't that crazy? There is one missing piece that we didn't cover yet in this video, despite going through the project's files and folders and explaining how React injects the app component into the div. We haven't yet discussed what a React component actually is. We still need to explore how components are defined and why they are considered the fundamental building blocks of any React application that you can see out there. Stick around for the next video where we will address these topics in depth. Until then, happy coding!